Gypsum sampling is the process of sample collection at regular intervals calculated in relation to the operating time and tonnage of a shipment with the purpose of obtaining one or more final samples. These final samples must represent, in terms of quality, the entire shipment sampled, so it is essential that the process is performed correctly. This process is always carried out in compliance with international quality standards and by experienced and trained personnel. In the case of gypsum, the samples are collected in strict adherence to the International Specification Standard ASTM. The minimum standard procedure for sampling is to take increments at regular intervals of 2 kg each until obtaining a gross sample of 90 kg. To fully comply with international standards, the SGS inspector takes increments of 3 kg at regular intervals until obtaining approximately 150 kg of gross sample by the end of the process. Sample collection of the shipment is taken directly at port during the loading of the vessel. In order to obtain a fully representative sample, it is taken whilst the material is in motion. The inspector arrives at the port and designates a work area where the process will be carried out in a safe and clean way and in which the necessary equipment will be placed. Riffle divider, shovels, buckets and bags, sieves, weighing scales and wheelbarrow. In order to take samples in a secure and representative way, a mechanical shovel is used. It collects material from various points along the entire stockpile, after which it is deposited in a safe place. This process is to be repeated at regular intervals. The inspector takes, from the material that the shovel has deposited in the appropriate place, 6 increments from different places which will then be chemically analysed for quality, and another 6 increments for size distribution analysis. As some loading operations expand extensively over time, several increments are taken. A quartering method can be applied with the purpose of reducing the weight of the mass sampled, but always obtaining the minimum standard requirement. Quartering is the method used by the inspector to reduce the weight of the sample randomly without creating a systematic bias. The increments taken for size distribution analysis are stored in specifically identified sample bags for later analysis. Once the last increments of the process have been collected, the bags are to be closed and sealed, ready for sample preparation on SGS premises. As for the size distribution sample, it is passed through the different sieves and then stored in different bags for subsequent weighing and obtaining results. Once the sample collection at port has been finalised, the preparation process is continued until the final samples have been obtained, which will then be chemically analysed in our accredited laboratory. On arrival at the SGS sample preparation room, the inspector unloads the different bags of quality samples to begin the final preparation process. Before starting this process, the seals and labels are checked to make sure they are the correct samples so as to avoid any errors. Before starting the process, all equipment is cleaned using brushes, vacuum cleaners and compressed air. In addition, to avoid any contamination, the equipment should be prepared by pre-testing it with some of the same material which will be treated later. The main and most important requirement for not losing representativeness is that in order to reduce the amount of gross sample obtained in compliance to the standards set, there must first be a reduction in particle size. To do this, a jaw crusher will be used to help reduce the size of the particles to 10 mm. After the initial particle size reduction, a weight reduction can then be carried out using a riffle divider. The process of quartering is repeated several times until approximately a 10 kg sample has been obtained. The particle size is once again reduced, this time to approximately 2 mm using another jaw crusher. Once the particle size is 2 mm, several weight reductions can be made using the riffle divider until 5 kg remain to then be pulverized. The final stage of the preparation process is pulverizing the sample to a size of 0.2 mm, which is the size needed to carry out the chemical analysis. A mill is used for this process and the entire sample will be passed through it. Once the entire sample is pulverized, it must be mixed and homogenized. To do this, the entire sample is spread out on a piece of paper and mixed using the wheel method. Subsequently, a layer is formed to divide it into 20 cells and extract a part from each one so as to obtain the final samples destined for the laboratory. The final samples will therefore be completely homogeneous and representative of the entire shipment. After the different bags which are destined for the laboratory have been filled, they are then sealed and labelled properly, thus avoiding any possible confusion and ensuring that they can be traced at all times.